Hello everyone, I, Mrs. Kishori Abhishek Kumthekar, working as Assistant Professor in Fulton Education Society's College of Engineering in Electronics and Telecommunication Engineering Department. Today we are going to see the practical of verification of Kirchhoff's current law and voltage law of the course Basic Electrical and Electronics Engineering under first year syllabus of DBA2 University. First, we see the statements of Kirchhoff's current law and voltage law. Kirchhoff's current law states that the summation of current entering to the node and the current leaving from the node is equals to the 0. And the statement of Kirchhoff's voltage law states that the summation of all voltage drops around any closed loop in a circuit is equals to the 0. For the practical of verification of Kirchhoff's current law and voltage law, we require this kit to perform the practical. On this kit, we have two circuits. First one is for the verification of Kirchhoff's current law and second one is for the verification of Kirchhoff's voltage law. First circuit is connected in parallel combination and second circuit is connected in series combination. The resistors connected in both circuits are having the value of 1 kilo ohm. The supply is internally connected to both the circuits. Now we check the connections and take the readings from observation. First of all, we connect the practical of verification of Kirchhoff's current law. The battery is positive, which is connected to the supply is positive. The battery is negative, which is connected to the supply is negative. For the measurement of I1, we kept open these two knobs, and I2 and I3 we get shorted. This is the observation table for verification of Kirchhoff's current law. Now we will take the readings. First we check the battery supply voltage, measure the voltage across battery, which is 8.9 volt. Then we have to calculate the current across I1. The current across I1, which is 5.97 milliampere. Now we have short the current I1 and I2 kept open. So the current across I2, which is 2.98 milliampere. Now we have to calculate current across I3. So we have to open the knobs of I3 and shorted the knobs of I2. The value of I3, which is 2.96 milliampere. The summation of I2 and I3 for the verification of Kirchhoff's current law. I1 equals to 2.96 plus 2.98, which is nearly equals to 5.97. So the addition of I2 and I3, which is 5.95 milliampere. Here the supply current and the summation of two outgoing currents, which is same. Now we see the practical of Kirchhoff's current law theoretically. This is the observation table from the practical. Now we calculate the value theoretically. First of all, we have to calculate the I1. I1 is calculated by I1 equals to VT, which is total voltage, supply voltage, divided by RT, which is total resistance. VT we give supply 8.92 volt, divided by RT is equal to total resistance. Here R1 and R2 and R3 are parallel to each other, so R1 plus R2, R3 parallel to R2. We connect the resistors of 1 kilo ohm, so I1 equals to 8.92 divided by 1 plus 1 parallel to 1 equals to the value is 5.95 milliampere. So the value of I1 is 5.95 milliampere. By the current divider rule, we have to calculate the value of I3. The value of I3 equals to the value of R2, which is 1 kilo ohm, divided by R2 plus R3, 1 plus 1, the value of resistors in kilo ohm, and the value of I1, which is the 5.95 milliampere, the value of I3, which is 2.97 milliampere. By applying the KCL at this node, we gives the equation I1 equals to I2 plus I3. Now putting the value of I3 and I1 in this equation, we get the value of I2. So value of I1, which is 5.95, equals to the value of I2, which is unknown, and I3, which is 2.97. By solving this, I2 equals to, we get the value which is 2.98 milliampere. Here the value of I1, which is 5.95, the calculated value of I2, which is 2.98, and the calculated value of I3, which is the 2.97. Here the observations from practical and the calculated values are nearly same. Now we will see the practical of verification of Kirchhoff's voltage law. Kirchhoff's voltage law states that the summation of all the voltages in a closed loop is equals to the 0. So the second circuit we connected for the Kirchhoff's voltage law, which the supply is positive, which is connected to the battery is positive, the supply is negative, which is connected to the battery is negative. For the measurement of current, here we shorted the values of current. This is the observation table for the Kirchhoff's voltage law. We have to calculate supply voltage and the voltage across R1, R2 and R3, and the summation of all the voltage drops in a closed circuit. Now we have to take the reading of current flowing through the circuit. The current flowing through the circuit is 2.98 milliampere. We have to calculate the voltage drop across the circuit. First of all, we measured the supply voltage. The supply voltage, which is the 8.92 volt. Now we measure the voltage across R1. The voltage drop across R1, which is the 2.96 volt. Now we have to measure the voltage drop across R2, which is also the 2.97 volt. Now we calculate the voltage drop across R3, which is also the 2.97 volt. The values of resistors connected in the circuit, which is nearly equals to 1 kilo ohm. So the voltage drop across all three resistors is nearly equal to 2.97 volt. So we take the addition of V1, V2 and V3. So the addition of these three voltages, which is 8.89 volt, which is nearly equals to the supply voltage V. So the verification of Kirchhoff's voltage law is done with the help of practical. Now we have to calculate the values theoretically for the Kirchhoff's voltage law. This is the observation table from the practical. First of all, we calculate the total current flowing through the circuit theoretically. The supply given to the circuit, which is voltage 8.92 volt, and the resistors connected in a series, which is each resistor having the value of 1 kilo ohm. So the total resistance equals to 3 kilo ohm. So the current calculated, which is the 2.97 milliampere. Now we have to calculate the V1, V2, V3. It means the voltage across R1, R2 and R3. The voltage across R1 we calculated by V1 equals to I into R1. So the value of I, which is 2.97 into the value of resistor, which is 1 kilo ohm. So the value of voltage flowing through the resistor, which is 2.97 volt. Same, V2 equals to I into R2, the value of current flowing through the circuit, which is 2.97 into the value of resistor, which is 1 kilo ohm. So the voltage flowing through the resistor second, which is also 2.97 volt. Again, the value of V3, which is I into R3, the current is 2.97 into the value of resistor, which is 1 kilo ohm. So the value of voltage flowing through the resistor R3, which is 2.97 volt. Here the values of voltage flowing through the circuit is nearly same, 2.97, 2.97 and 2.97 volts. By practically we have the value of 2.96 volt, 2.97 volt and 2.97 volt. The practically and theoretically values are the same. So here the Kirchhoff's voltage law is verified by the practically and theoretically. Thank you.